Hi, welcome to AP Chemistry Daily, Topic 1.2, Mass Spectroscopy of Elements. I'm Kristen Cacciatore from Charlestown High School in Boston, and I'm happy to be here with you. So this video is about practice with mass spectroscopy. Let's talk about how it shows up on the AP exam. There's three basic types of questions, and we're going to go through one of each. Estimate the atomic mass from mass spectrum. Could be a fictitious element, sometimes that happens. We have identifying an element from a mass spectrum and identifying an isotope from a mass spectrum. So all of the questions tend to center around graphs around the mass spectra. All right, so let's look at this first one. What is the approximate average atomic mass of chlorine? So stop your video here and give this a try, and I'll be back to go through the answer with you. All right, so what is the approximate average atomic mass of chlorine? So for this, we need to identify the isotope masses and their percent abundances from our graph. So we have 35 atomic mass units. That's this first bar on the left. And if we read over on our y-axis, that's about 75%. And we also have a second bar, 37 atomic mass units, and that's going to be about 25%. Next up is we multiply each isotope's atomic mass by its relative abundance, which is the percent abundance divided by 100. So 35 atomic mass units times 0.75 and 37 atomic mass units times 0.25. And then to find the approximate average atomic mass, we add the results. And when we do that, we get 35.5 atomic mass units. We'd round to 2 sig figs because the precision of our graph over here on the y-axis is very low, and that would give us 36 atomic mass units. And if you look on your periodic table, the atomic mass of chlorine is 35.45 AMUs. So we did pretty good considering, again, the low precision of our graph. All right, let's try another problem. This time, we're going to try to identify an element from a mass spectrum. Which element's mass spectrum is shown in this graph? So stop your video here and try it on your own, and then I'll go through the answer with you. All right, so here we're going to try to estimate the average atomic mass, roughly speaking, by looking at the graph. So let me show you how I think about this. 39 atomic mass units is clearly the largest fraction of the atoms here. It looks like it's a little bit more than 90%, so about 90%. And then we have two other isotopes, 40 and 41, that are a much, much smaller fraction of the atoms of this element. And together, they're going to be about the remaining 10% of atoms. So what does that mean for the average? Well, the average is probably going to be a little bit more than 39 because most of the atoms are 39, and then we have a few atoms that are a little bit heavier. So I would guess that the atomic mass, or I would estimate it as being a little bit over 39. So I'm going to head over to my periodic table and see where that gets me in terms of identifying an element. A little bit bigger than 39. So I look on my periodic table, and here it is. Potassium, K, is 39.1. That's just about what we said, right? A little bit more than 39. If I look at the two elements near potassium, calcium is over 40, and argon back here on the right is almost 40. And it was pretty clear from that spectrum that the atomic mass was closer to 39 than it was to 40. So I think we can identify this element as potassium. And in fact, we are right. It is potassium. Potassium has 3 isotopes, 39, 40, and 41. All right, let's look at one more. So identify the element and the number of neutrons in atoms represented by the peak at 74 AMU in this mass spectrum. So stop your video here and see if you can think through this problem. Okay, so let's figure out how to identify an isotope from this mass spectrum. So the peak that we're asked to focus on here is 74 AMUs, so I circled that. So first we need to figure out what element this is if we're going to identify the isotope. And so we're going to use the same strategy that we did in the previous slides to identify the element. So the atomic mass of this element is between 72 and 73 based on estimation. So let's take a look at how I did that. Well, it looks like about 50% of the atoms are either 72, which is almost 30, or 70, which is right above 20. And 50% of the atoms are 73, 74, and a few are down here at 76. So based on that, I can estimate the atomic mass as being between 72 and 73. So I go to my periodic table and I look to see what I can find. So the element that has an atomic mass that's between 72 and 73 is germanium, or Ge. And notice that the two elements on either side that have the closest atomic masses are nowhere near 72 or 73. So gallium is 69.72, it's below 70, and arsenic is almost 75. So I think it's pretty clear that this has to be germanium at 72.63 AMUs. So then I'm going to go back and focus specifically on the peak at 74 AMUs, because that's what I've been asked to do. So this is the spectrum of Ge. I need to know how many neutrons are in this particular isotope. Well, remember that neutrons and protons together make up the mass number. So to find the number of neutrons, I take the mass number and I subtract the number of protons, or the atomic number. And when I do that, I arrive at the answer. There's 42 neutrons in this particular isotope. So the final answer, this is Ge74 with 42 neutrons. That's pretty much the most complicated problem that you'll see on mass spectra on the exam, at least historically speaking. All right, thank you for watching, and I hope we'll see you next time.